Hi guys. I think I'm the last one before lunch, so yeah, almost there. Also a bit hungry, but still good enough to tell you about how to migrate virtual web apps to virtual reality. Then we will talk about how virtual reality works in Essential and why it might be needed, and then how you can do that. Yeah, my name is Denis Radin. You may find me as a pitfalls commander online. I work in Evolution Gaming in Amsterdam office, not in Riga. And then the question to you guys. Amsterdam office, we use some things on a daily, regular basis. Legal stuff for characters in Amsterdam office of Evolution Gaming. Coffee in Latvian, right? It's going to be for characters. Yeah, we use it daily, but also daily we use GLSL, which is OpenGL shading language. And essentially what we do there in Amsterdam office, we do games with React and WebGL, mixing these two technologies. It's some small demo of what we do, and then, okay, there is some graphics and some UI interface is developed with React. Also, we not just making a production, but we concerned about entertainment trends and all funny things which are happening there, because it's not just a business side of development. So, and if you look about that, display might be not a good choice to play some immersive games in recent time. Probably, how many people already played VR? Yeah, quite a lot. Nice. So, actually, it was predicted, so many people will try it and many people will buy it. I personally have Oculus at home, some of my friends have, and it happens slowly. Like, there was a high excitement on VR a few years ago, but it still happens. Like, people buy VR just for home, just for some gaming. Not that many, then it's still slowly growing. There are millions of devices already. So let's talk about the reason why the hell I would like to drop my web application to a virtual reality. Okay, for example, so you made a car customization app. Customization app where you can pick a color or yes, exactly. So Accenture, I'm selling you expertise. So let's chat after that. So you made a car customization web app. Tune interior or exterior of a car, and then you can drop it to virtual reality with if you know the approach, and add a customer and a client and user some additional experience. Or you made a real estate catalog as a web app, and you can drop it to virtual reality and make a virtual tour together with picking your property. So it basically makes some sense, especially if you know that there is a revolution happening now in real estate, which is a Project Tanga. Project Tanga is a tablet with a built-in LiDAR, which makes it possible to make a map of apartment or house just by walking with this laser scanner, and then you have a 3D map with a texture in it, a photorealistic one. I'll try to show video. So basically, you just walk with the camera, and then after you have a 3D map. Happens like that. As easy as just walk a few times around. It's a really useful tool for real estate agents. If they're selling a house for a few millions, then clients might not come to a property to Switzerland and just look it from Riga, buy a house in Switzerland. Okay, let's go further. So virtual reality provides new experience for customers and some new fun for us, for developers. Yes, but we should understand that if we just drop a web application as a flat sync into virtual reality, it would be not that fun. It's going to be the same way we have it on a display. So to make it really immersive, to make it cool, we need to do it consistent and continuous part of virtual reality, of environment, to give it a 3D feeling. If you see the difference, so just drop in a browser into virtual reality would not work most likely, because the experience is not designed for that, and basically doesn't impress. So it was an important point. Okay, now let's move to how virtual reality works. It works because you have two eyes, essentially. So there are two images, every of them is given by a bit different angle. Then you have two displays or one single display. Okay, it's just fun. And then the bad part of virtual reality that when you design software for it, you do it in imperative way mostly. And then if you design for WebVR, like for 3JS or Babylon.js, then it might be a bit tricky because it's code for some very simple things, a lot of imperative code. And for us as a CSS HTML guys who can do that in a few minutes, like displaying an image just with one line, it's a bit sad. It's a bit step backward. A lot of code to display one image. Set up sprite, load texture, and so on, so on, so on. But then, yeah, let's see what interfaces in virtual reality looks like. So this is an interface from Oculus Rift. One of okay, let's switches. So it's nothing special actually. We can easily re-implement it with CSS and HTML, and it can easily be virtually. It can be CSS 3D app, right? Some divs, some images, and then maybe some hover effects. Enlarging them. Oh, this one is from Daydream. Daydream is, if you know it, it's Android version of virtual reality. Maybe there is something which we can't re-implement with CSS and HTML. That actually also looks quite CSS-ish. We still can put it as divs in some 3D space. So there is nothing that much special for us. And potentially we can get rid of all this mess of using imperative 3D engines by just dropping a web application to virtual reality, something like that, and use it there. Well, we can easily do it with HTML, CSS, if we can drop it to virtual reality. Oh, okay. So the first try to get it work, of course, was CSS 3D, because CSS 3D is a cool thing. You know, most of you probably have seen this cool demos of CSS 3D driven. All the thing is built with CSS 3D. It means every surface on the scene is a div, which is rotated by 3D transformations. Oh, CSS 3D is kind of powerful. We can do some 3D stuff, and we can position things in 3D space. Oh, this one is combined out of radio buttons with CSS 3D transformations. Yeah, okay. Nothing exciting, just CSS 3D. So potentially we can do two eyes, two iframes, which is also a nice game of words, eye and iframe, and it might work. Like on one eye we put the CSS 3D scene with 1 degree, and to the second eye with other, and actually there are a few problems there. CSS 3D would not fit, even if it looks like a very good approach and a very cheap approach, natural. So there is, first of all, there is a delay between iframes if we try to do that. But even if, okay, yeah, we have iframe, for example, one is a master, then you change something in app, and one iframe, then you need to send this to another one. It can be solved potentially, but by having some master iframe and just sending signals immediately to both. But still, the bigger problems of using CSS 3D is the way virtual reality gives us a space, gives us a field of view. Like normally, if you put a device to your eyes, you will have a very narrow field of view. So to make it wider, it uses lenses. So device have lenses on both screens which expand your field of view. And this is how it looks on a display. So basically the stage is wrapped in a way that optics convert it to a normal picture, but then with a wider field of view. And this is a big problem for CSS3D. You can't make this kind of effect. You can't wrap a picture in this way. Oh, yeah, this is just not possible. And the problem number 3 is the chromatic aberration. This is a minor one, but still, like really nice virtual reality experience is not possible without chromatic aberration. Chromatic aberration is an effect which happens because of light distortion on an eye, and it basically looks like on the edges of your side of seeing, you have this kind of rainbow effect. You don't see it, but when virtual reality application doesn't have it, it doesn't feel natural. And also in CSS3D, you can do that. So to be able to reproduce all these effects, this distortion for field of view and chromatic aberration, you need legal stuff from Amsterdam, GLSL, shaders, so OpenGL shaders. And this can work as a part of WebGL. In WebGL, we have the shaders, and it can be a WebVR application. Our WebVR application is basically a set of APIs, and many heard about that. There were a lot of talks about that. Set of APIs to work with virtual reality devices, and it includes WebGL, of course, for display an image, and then there are a set of APIs to have data from VR sensors. Oh, there are some really nice things like VR display request animation frame, because request animation frame for display and VR request animation frame for a virtual reality helmet are different. And of course, you can get position acceleration of your helmet to reflect it in virtual reality. So yeah, the good thing about WebVR, which we're trying to engage, is also that it's open technology. And Oculus and Vive, if you tried it, they have a storage. Like, it's closed ecosystems, and WebVR is cool because it's open. So basically, you open a website and you can use it. And WebVR support is, there are version of Chrome and Firefox which supports WebVR out of the box. So it works. Don't need to download. Okay, you need to download, but you don't need to install. And yeah, many companies bet on WebVR. You know, even Facebook built a React VR, which also WebVR thing, but not only, but yeah, it also supports WebVR. It mostly uses 3.js, but can be also used with other languages, or with other engines, sorry, and Babylon.js we use in Evolution Gaming. But still, the problem, if you try to do WebVR, which is capable that displaying an image in HTML for 3D engine looks like that. So you need to set up a sprite, load a texture, and add it to a scene. So it's something actually we've seen before. Oh, there was another problem. So many years ago, I was developing JavaScript-based operation system for a set-top boxes in a company called Liberty Global. There were a lot of challenges on performance. So they bought 5 million of these boxes, and then boxes were not that much performant. So for many years, we tried to tune performance of these boxes. Okay, you got 5 million devices, and they doesn't perform. So basically, your software doesn't work on them properly, so you try to optimize hardly. So there was a special team I was a part of, and we've been optimizing all the shit with CPU, GPU stuff, and so on. Who've seen this movie? Yes, with Ghostbusters. 1, 2, 3. Okay. It's quite a lot, but still less than 30%. So I think we can proceed with it. Oh, let's see the movie, which shows you the difference between CPU and GPU. It's a movie from Mythbusters show. It was all basically... Oh, after many years of investigations, we found that the biggest change you can do, you can optimize JavaScript, you can optimize many different things, but the biggest switch you can make in performance is if you start using graphics with GPU, not CPU. That's how it's done with CPU. So CPU thinks where to put every pixel. And it takes some time. But then GPU does parallel computations. which gives you completely different kind of power. Go! Yeah, that's the power of parallel computations. Yeah, so GPUs separate textures and they apply textures to a driving surface very quickly. Our lesson learned was, okay, the CPU is like a hardly working kid, like trying to draw every line and make it nice. So thinking about every pixel, and GPU is like a stamp. Just put in stamps, put in stamps. So modern GPUs are very amazingly powerful, and they can handle millions of textured surfaces. So yeah, so many because you need really a lot of polygons to display photorealistic images on in games and some other applications. And we were talking about that, but OpenGL OpenGL is the interface to work with GPU. One of interfaces available. OpenGL can be used in a browser as a WebGL. And if you think about that, you can present every div on your web page in your web application as a texture, like as a textured surface, and millions of them can be handled with the GPU. And let's see. Let's see how many. There are these textured surfaces. We can see them as divs, as animated divs. Then let's add some animated divs. So it goes with 7,000s, 10,000s, 15,000s animated divs. Work quite nice. So when I add, it drops the FPS, but then it works nice. Still 45. Okay, let's do at least 20,000s. Maybe more. Okay, 25,000s of animated divs. With HTML, CSS, it's definitely not possible. With WebGL, it is. Yeah, but why don't we use WebGL then for every scene we see around? Just because, again, it's imperative. It's really hard to write this code, and you need a lot of time to do that. And it's verbose, and yeah, we run into the same problem as I mentioned before, because we are really spoiled. We are spoiled by HTML, but we are spoiled in a good way. We are not used to this imperative big things, and yeah, they make us sad. And then, after this performance research, we pop up with a project called HTML-GL, which was kind of wrapper for your HTML content. You wrap some HTML content in the HTML-GL tag, and it starts to render with WebGL. And it's not only about performance. Actually, it was possible to do quite interesting things with this image is especially long to load. I don't know why. All right, so it's loaded, then it applies, on load, it applies effect. What we see here is HTML application. We still can inspect it. We can even change content. Hey, Riga. Yeah, and it automatically re-renders it to, hey, Riga. So basically, we still have our DOM. We still have control over HTML and CSS. It's all built with all those things, built with CSS, and there are, of course, mouse handlers, as it should be, with add listener. Oh, you just write a normal HTML application, and then it's dropped to HTML just by wrapping your content into HTML gel tag. And a cool thing with shaders, cool thing with WebGL is that your possibilities are not limited at all. I mean, you can do really funny things there with your content. Of course, this doesn't make that much sense, but I really love the fact that HTML content can be that easily transformed, and yeah, something which is not there for a normal web. Yeah, there was some goodies for font gap as well. Oh, this one is okay. And then, yeah, we did that. It worked on these boxes. WebGL, we found the most performant way of displaying interfaces, and some parts of operation system was displayed by in WebGL. Then it was completely 2D, and one day I got a ring from Sony, and they said, hey man, we are making now a big bet on virtual reality. And if you know that Sony renders whole interface with WebGL, so it's browser, but they render interface with WebGL on the platform, so they're heavily involved into this kind of writing JavaScript-based operation systems, like Sony. Wow! And the question from them was, Dennis, can we drop application to a 3D space with your HTML library? And I said, no, you can't. And it was really, really not cool. And I felt that that's a challenge, and it was, you know, sign from destiny that I should do that. And 1 year later, I not released, but it's there in the branch HTML.jl v2 branch. You can find it on the GitHub. So there is HTML.jl version 2, which is approximately 10 times more performant in re-rendering, and then it's have better sync with DOM and styles. It's pluggable in terms of renderers, first of all. So you can render to 2D space, you can render to 3JS, Babylon.js, and 3JS plugin means WebVR. And not only about porting existing apps, just for adding cheaper way of adding interfaces to 3D apps you already have. So yeah, just less code. This one can be replaced with the image or whatever. It means that you can create UIs quicker. Okay, let's have then some demos of version 2. So, first of all, it goes, okay, I should set a bigger font, I think. Yeah, so it's just some web page, right? So some divs HTML.jl container. This is crucial to remember. And then there's class carousel, and there are 2 items in the carousel: first item, second item, right? And some JavaScript code, which on mouse over it makes it bigger, and then when you press a key, it just animates a slider. Yay. So it actually makes bigger, and you can move it left and right. Nothing impressive, right? Then it's actually a 3D space. And it's a 3D space, and it's already a WebGL, so it's not web content. It's a 3D WebGL, which you can apply all kind of filters easily. Now there is just a plugin for 3JS called VR for 3JS, which breaks it into two pieces for two screens, and applies field of view distortion and harmonic aberration, and it catches changes into DOM. So if you change a DOM, it re-renders and updates your image. Okay, let's go for something more interesting. Okay, let's proceed with this one. Oh, also you can apply some interesting light effects with this. It might be not only used for virtual reality, but then in overall having this dynamic light, so you can make something like a spotlight. It's a kind of Oscar application. It's still web app, right? So no this 3D code, no this big JavaScript definitions of a theme. So it's still HTML. This one was a try to find a lot of money. Okay, if I do application about expensive yachts, then I will have a lot of money because this yacht costs 1.5 million at least. Oh, yeah, and then the nice thing here is that our HTML content becomes a really continuous part of a 3D world. So we see here is that there is a reflection, which is a quite interesting shader, and then still you have a reflection of HTML app. It's like not just applied on the top, because there were some companies experimenting with a mixed mode, like they're putting HTML content on top of WebGL, but then it never gives you opportunity to apply effects to HTML content. So putting on top doesn't mean that it becomes a part of a thing. Right, and then one more demo was I just went online and took on GitHub, and I took the calculator. It was a copy of Apple calculator done with JavaScript, HTML, CSS. And, yeah, we'll close the steps. Still consume some resources. Yeah, so that's essentially, by the way, it catches a microphone. So, yeah, so it was experiment on porting a real app into virtual reality, and it works. Like you can drop your app potentially as well into some interesting space, and it will give some additional meaning to what you did. Right, now let's go to 2 slides. So how it works in essential, once you wrap a thing with HTML-GL element or apply HTML-GL with a JavaScript, there are 2 ways of doing that. It's being rasterized to texture, so your diff is being converted to texture. And there are 2 kind of transformations there. So one transformation required to re-render this texture, and this kind of transformations are slow. Like it's, for example, if you change a font, then it's going to be a re-render and it's going to be slow. But if you do something like a movement or rotation or opacity change, then this one is going to be quick and it's just applied as a shader, as an effect to texture on a WebGL surface. Then talking about plans, interesting things you can do. So VR can be a part of experience. So we've seen there is a mobile websites, but what can be also interesting, you can have a VR subdomain and have VR experience for your web application living on a subdomain like it was with the mobiles from the beginning. It might be WebVR as a progressive enhancement. It's possible. WordPress plugin for WebVR, also interesting. It can be quite immersive. So if you build a fishing equipment shop, you add some fishes and water there. It might be fun. And then a-frame plugin for HTML content. Do you know about A-frame? I think no. No, it's a really interesting thing. It's a framework to build VR experiences with web components. So it doesn't allow you to bring your web application to a virtual world, but it allows you to build, like for example, they have text 3D model, and then with text 3D model, you can easily, declaratively drop something to 3D space. It's easy. Oh, let me. It's quite slow one. Stop downloading torrents, please. All right, I'm not sure will it load or not. So A-frame, you put a text 3D model, SRC your model, and it displays on the screen. Oh, basically in an HTML way, you can build some 3D scenes with A-frame. Currently, I think it's the best way of building WebVR experiences. And if you would like to play with WebVR A-frame, it's a very interesting approach. But it's not about UIs. It's more about putting models, making them work together, and so on. Oh, the interesting thing to try would be a text rendering optimization with SDF, which is a quite quick approach to render fonts. So currently they've been rasterized as browser do, but SDF can reduce the time for a render significantly. One more educational thing we can talk about is React VR. Many people probably heard of, because React is currently still on hype, and React VR did a lot of noise when it popped up. And the idea behind React VR is that it can render to two platforms. So it can render to WebVR, but then it also can render to native for a platform, for iOS, for example, or for a Oculus embedded device. Then there is not too much now from React VR to be heard, but I know they experiment a lot with React VR, with AR. They're trying to build business model around, but technology is there. So if you're a fan of React, you can build virtual reality experiences with your framework of choice. And again, examples, nice. Finally we have them. That's essentially a code of A-frame. So you put a box, position this, rotation Z, color. So it's very declarative, very nice way to describe a scene, to build VR experiences. This one is more complex, I believe. It's still entity animations, also declarative. Nice framework. It's kind of promise of it is have React kind of experience without transpilation. If you compare now A-frame and React VR, React VR is probably a bit less powerful than A-frame, surprisingly. Yeah, for React VR you may also check a website. And currently it's called React 360 on Facebook, GitHub. Right, so that's it. Thank you.
I didn't see any questions on Twitter, but I have actually a couple of questions.
Sure.
So, what's like the minimum required equipment to get started? I saw that you did everything on the laptop, but like, what's the cheapest way how I can get the VR thing on my head?
VR thing. Oh, I think the cheapest one is to have just, you know, SCART box. This card box works essentially with any device, so you just put a mobile device there, but it's not the first class of experience. Currently there are a lot of VR devices from different vendors. Chinese one developed. Of course, A-class quality, it's Oculus and Vive. Yeah, but there are a lot of on the market. And the price for the cheapest one, I think, is around 100 euros. But currently you can buy Oculus for 300 euros. So it's not that expensive at all.
And what are like interactions like in these web VR applications? Does text highlighting work? Like how those things work?
Yeah, it can work with the hover. Like it catches style changes, so doesn't matter what you do. It catches the style change is going or render or apply transformation.
Anyone else? Going once, going twice, 3. Thank you.
Yay! And now, hey. Oh, cool, man. Thank you.